Welcome back to Mind Maths with Amina. Today I'm going to continue solving the sample examination questions from chapter 2 on data visualization and descriptive statistics given by the study guide by University of London. I'll walk you through how to construct a box plot using raw data and how to interpret its shape and what the distribution tells us. The data set over here, as you can see, is already ordered from the lowest to the highest value. The question goes as follows. The average daily intakes of calories measured in kcals for a random sample of n athletes. So the value of n is 12. The interquartile range is basically the upper quartile minus the lower quartile. Before I construct the box plot of this data, I've just, to save time, I've drawn the generic box plot where Q2 is the median, Q3 is the upper quartile, and Q1 is the lower quartile. And I wonder what this is called. The end lines of this is basically the smallest observed value, which is not an outlier. So either it is the smallest value or it is the lower quartile minus 1.5 multiplied by the interquartile range. And just like the smallest value observed value being here, this is going to be the largest observed value. The minimum between the largest observed value or the upper quartile range, actually there's a typo here, there should be upper quartile range Q3 plus a 1.5 into the interquartile range. Okay, so let's solve this question. So let's find out the median. Since n is equals to a 12, so n plus 1 over a 2 is a 13 over a 2, and which is a 2, 6 are 12, so 6.5th term. So what this means is that our median is going to be the average of the 6th and the 7th term. So since our data set is already ordered, let's see what the 6th term is. 1, 2, 3, 4, 5, 6. So we want the average of 2101 plus 2147, and that's going to be our median. We will need a calculator here. Let me take it out. I should have actually taken it out before I started this lesson. Anyhow, 2147. Okay, so this is a 4248 divided by a 2, which is easily 2124. So that's the median. Okay, now let's do the upper quartile. So the upper quartile is basically 75% of all the entries lie below this. So we have a 3, 4, n. So 3 over 4 into a 12 is 4 3s are 12, 3 3s are 9. So this is going to be the 9th term. So let's write down as this being the 9th term. So the 9th term is 1, 2, 3, 4, 5, 6, 7, 8, 9, 2200. 2200. Okay, so the lower quartile, for the lower quartile, 20% of the whole data lies below this. So actually 25% is a 1 by 4 into an n. So we have 1 over 4 into a 12, 4 3s are 12. So the lower quartile is the third entry in our data set, which is a 1957. 1957. Okay, so we have this, we have this, and now we have this. There are two other things that we need to calculate. First, we need to find the minimum of the highest entry, oops, let me erase that. Okay, let's do this. So the highest entry in the data set is 3061. So 3061. And the upper quartile is a 2200 plus 1.5 into the interquartile range. The interquartile range is a Q3 minus Q1. So that is a 2200 minus 1957. Let me see that in my calculator. 220 minus 1957. Oops, it was a 220. 2200. Okay, 243. So multiply by 243. So I need to multiply 243 into a 1.5 and add it to 2200. So the minimum of 3061 and 2564.5. So the minimum of this is a 2564.5, which actually tells us that this entry of the data set is the outlier. Okay, next we need to find this, the maximum between these two. Okay, so the first entry, the lowest value in the data set is 1808. 1808. 30, 60, okay. And we need the lower quartile minus 1.5 into 243. Let's take our calculators out. A 243 into a 1.5 is a 364.5, and we need to deduct this from 1957. So the answer is the maximum between 1808 and 1592.5. So the maximum is 108. So this is not an outlier. Okay, so let's make a rough sketch. So the lower quartile is a 1957, and the upper quartile is a 2200. The median is a 2142. So 2142, and the edge. Okay, so this edge over here, there's an edge here. So we have a 1808. This is where it ends, and this is a 2564.5 there. So we can see that the data point 3061 is actually an outlier, because it lies outside our, actually I should just end the box here, and I should just make it over here and just show that this last value lies outside the box plot. 2,500. Yeah, the 2,500 is actually below this. So all the other entries are, the only outlier value is a 3,061, which is why the medium is actually going towards the right. So based on the diagram, even though I didn't really draw it to scale, but I can see that the data is positively skewed. And one reason being that the medium is closer to Q3, but because of this outlier, we are going to get data which is skewed towards the outlier. So it is positively skewed distribution, and the reason being we have a outlier due to the outlier of 3061. So we should expect the mean to be greater than the median, and then the median to be greater than the mode. What other ways can we represent this data? Usually a histogram is used for such a data set, or a stem and leaf. And actually even a dot plot is good at seeing the distribution, the type of distribution. So even a dot plot would do. Because the data sets here are measurable, so the graphs that are suitable for measurable variables are these three. So that brings about an end to the sample examination questions. There are actually more questions available in the study guide for this chapter. I'll solve them as well. As a conclusion, if you found this helpful, don't forget to follow along for the full statistics ones playlist, where hopefully I'll get time to solve every chapter and all the questions given in the study guide. Take care for now.